Point P lies on the line with the equation y equals 4 minus 3x. The point P is the distance of the square root of 34 from the origin. Find the two possible positions of P. So that means P can intersect that line at two possible points. Got a lot of information. First things first, sketch it so you can see what it looks like. So let's draw our grid. Let's draw the y axis and the x axis there. Okay, not quite long enough. Oops. Okay. My x-axis, that's my y. I've got y equals 4 minus 3x. Let's draw that in a different color. Let's go dark blue. Okay, so y equals 4 minus 3x, negative gradient, intersecting the y-axis at 4. So it's going to look something like that. Let's try again. Let's try again. Yeah, that's a little bit better. Right, so that's our line, y equals 4 minus 3x. And then we've got this point P. It's the distance of square root of 34 from the origin. That's our origin there. So from there, it intersects the line either there or there. So that means it has, because it's the same distance from the origin all the time, it has a circular ellipse, which means, well, basically it's a circle. So if we sketch a circle around the origin, radius of square root of 34, see, from about here, there we go. I think we could do a better one than that. Forget to hit circle. Yeah, it's better, a little bit larger. Not quite. Let's try one more time. Yeah, that'll do it. Right, so it's got a distance of the square root of 34 from the origin at all times. Okay, so that's the square root of 34. Right, now it intersects the curve and the circle intersect here and here. So the distance from the origin to where it intersects is the square root of 34. Let's use a different color to show that. We use red. And from the origin to the intersection, it's going to be the square root of 34. And we need one more, because we're going to go from, again, from the origin to the point of intersection, which is there. So we can use either one of those. Now, to find the equation of the circle, what we do is we join it up, and I'll need my pen again. We join up that point of intersection to the x-axis. So that's our point of intersection, and we join it up there, like so. So now we have a triangle. And that triangle is what we're going to be looking at now. Just want to highlight the triangle we're looking at from here to here, here to here, and from here to here. We could do it with the other triangle that intersects, but it's a bit of a smaller one, so we'll use this one. The equation of the circle is the same wherever we're working from. So that means this distance from the center of the circle to the intersection is square root of 34. This distance here is from 0 on the y-axis to a point y. We call this point, say, x, y. So this distance here is going to be y minus 0, and this distance here is going to be from a point x minus 0. Now we've got a right angle triangle, so that means I can use Pythagoras to solve this. That's going to mean that x minus 0 squared plus y minus 0 squared is equal to square root of 34 squared. So x minus 0 means x squared plus y squared is equal to 34. And that's the equation of the circle that goes around the origin. Now I've also got another equation which tells me that y is equal to 4 minus 3x. Second equation. So I've got two equations and I've got two unknowns. So I can solve for x and y by substituting. So sub for y in equation 1. And I think you can go from here, but I'll just get you on your way. The x squared plus 4 minus 3x squared equals 34. So now you expand and simplify. You'll get a quadratic equation which you solve for x. Once you've got your 2x values, you sub back into this y equation here, and you can find your y values. So that's how you solve it. If you have any more problems, see me, and good luck completing that.